All right. Well, thank you for having me here. It's a great pleasure to talk about what we do every single day. We try to solve problems, we try to innovate, we try to deliver value. So I want to talk about what are some of the challenges that we go through in that process. So let's talk about what I want to call as don't walk away from complexity, but run. I work with different companies. I consult on projects. And oftentimes when I walk in, what I notice is they have tangled themselves into enormous amount of complexity. And these complexities make it really hard for us to produce value and move forward. And oftentimes it becomes a real huge barrier for agility. So that's what I want to spend time on today talking about. When I was a child, I used to say a lot of scary stories. Now I'm grown, I just talk about programming. I think that's even more scarier actually. And so I want to talk about some of those stories. And so this talk is really about stories of my experience, my observations, things I've seen in the field, and things I've learned from observing projects in the industry. That's what I'm going to talk about predominantly today. So when it comes to this, of course, we've heard that the only constant is change. We constantly have to keep up with change around us. The change comes from change in requirements, change in environments we work in. The change comes from the nature of problems we have to constantly solve. So the change is what we do every single one of the day. That's our profession that we live in. But the question really is, what really makes this hard to keep up with those changes? Well, it turns out that complexity really makes it hard to keep up with change. And the more complex the systems we build, the more complex we create solutions around us, the harder it becomes to really make those change over time. And well, really think about it, let's not be naive about it. System design is complicated by nature. We're not in this business to run away from the details of things we have to deal with. But there are two kinds of complexities we have to deal with. And the first complexity is called inherent complexity. Inherent complexity is the complexity from the problem that we are solving. If you're in the banking industry, there are complexity related to the transactions you have to deal with every single day. If you're dealing with medicine, there are complexities you have to deal with the field of medicine. So those are inherent complexity. You cannot get rid of those complexity. But unfortunately, what we deal with most of the day is not just that inherent complexity. What bogs us down is what I want to call as the accidental complexity that comes from the solution space. So the solutions we often use ends up being complex, and in the process, it really makes it hard for us to maintain the applications and make the changes when we really want to do. So my goal here is for us to be able to identify these accidental complexity and then remove those accidental complexities so that we can then focus on and manage effectively the inherent complexity within applications. So from that point of view, sadly though, we add complexity to code, we add complexity to the problems we are solving as developers constantly every single day. And being cognizant of that is extremely important. Well, we are victims of our own complexity, and we create complexity, and then we get dragged into it. We call these the self-inflicted wound. We cause it on ourselves to do this. Well, Einstein said it takes a touch of genius and a lot of courage to move in the opposite direction to make things simple, and so to be able to recognize complexity is one of the very first things we need to really think about. So I want to ask the question, what really makes systems really complex? What causes that? Well, there are several things I've observed that causes complexity, the accidental complexity I mean. And I want to outline some of those things maybe we can identify, and then maybe we can recognize those when we develop applications and say, hey, that's going to lead to accidental complexity. Let's eliminate it, or at least minimize it, so we don't have to get sucked into those complexities in the field. So what are some of the things that lead to such complexity of systems? The very first thing is too many moving parts. We do this a lot in programming. Moving parts really make life miserable. So what are moving parts? Moving parts are when, to put together some solution, you have several parts and the parts keep changing all the time. And this is more and more today in the world we live in. We're living in a world where we're creating solutions with microservices, we are creating solutions with distributed systems, we are creating solutions with hundreds, if not thousands of libraries and dependencies. So we get really dragged into these moving parts a lot. And moving parts make our life really hard. If we can take the time to reduce the moving parts, that itself is an improvement already. Well, Leslie Lamport famously said, a distributed system is one in which the failure of a computer you didn't even know existed can render your own computer unusable. That's a very profound way of thinking about it. We're living in a world where we are depending on services we don't even know that exist today, and the systems that we are using are so integrated with other systems around the world, you won't even know where these things are coming from and where they exist in reality. And when it comes to these, I've noticed a few things in my observations. In particular, I remember one experience. I once worked with a company where they were developing a software that was pretty intensive for the field that they were in. I'm trying to be a little vague here because I'm being recorded, so I usually don't get too specific about things. But one of the things I noticed was they were deploying the product for very many different clients. And when they called me to help them on the project, I started learning about the application and how they are building. And then I noticed they had a desire to make their code extensible. And in the desire to make it extensible, they had created a configuration file where every single detail you can ever imagine was configurable. Well, the beauty of this product was it is so extensible, but when they found a new client to sell the product, deploy the product, they literally needed 6 months to configure the application because there were so many things you had to go in and configure. This was configuration from hell. And you're trying to really configure all of these, and excessive configuration information is making things extremely hard and brittle. And unnecessary components, unnecessary dependencies, and way too many layers in application. So many layers in the sake of extensibility and ability to provide flexibility that as a developer you come in and very quickly you lose track of where you are and what else you have to deal with. And at some point you ask the question, for the problem I'm trying to solve, do I really need all of these things to be working with? And that becomes really painful over time. And recognizing that and refactoring the application constantly to reduce all that accidental complexity is extremely important. Otherwise, what happens is the system becomes very brittle. And the code becomes very error prone. We keep chasing behind bugs all the time. Another problem with this is it's extremely hard to deploy. It takes enormous amount of manpower, time, and effort to deploy these applications. And another really early sign of warning is how hard is it to test your application? If your application is generally hard to test, it's a sign of a weakness in the design. I often tell people, if somebody tells you this code is hard to test, what they are telling you really is the design of the system sucks. So it usually is a reflection of the quality or the lack thereof design when it comes to testability of applications. And the system is extremely hard to reason. If you sit down with somebody and say, how does this work? And they get tangled up, they're not able to describe how the application actually works, and that's something to really think about. Well, we talked about moving parts. The other thing I've really noticed in applications is when there are invisible changes. This is very annoying. This is one thing we need to do as developers is ask the question, am I making this very clear for the person reading the application? And if it is not clear for the person reading the application, it's our responsibility to really make it very clear so that the person reading the code after us could be ourselves 3 weeks from now or after a long vacation, and we want to really be able to understand what the code is doing. So we want to really avoid these invisible changes. I remember somebody asking me, hey, we got this application written in C++. Would you do us a favor, read this application, understand what this is, and could you please re-implement this for us in Spark? And to be fair, though, it was not a very big application. It was maybe about 300 to 400 lines of code. And I wanted to read and understand this code before I really rewrote it in Spark. And I started reading the source code. And I'm sitting there like an idiot trying to understand what the code is doing. And I'm walking through the constructor and literally stepping through the code. And I make a jump in a function. And the function really is, the name of the function did not give me any indication what that function is going to do. And I step over the functions, and suddenly this object, which doesn't have a whole thing, is just populated with a lot of data. And I'm not kidding with you, I spent 30 minutes in this code, and then I literally started stepping through every line of code that's called from the constructor, and that's when I realized deep down in a method, they suddenly go back and start changing objects that they had access to. And I can't tell you how angry I was when I came across this. My wife often says this. When she watches me program, she comes to me and says, I don't understand this from you, Venkat, because you're the nicest person I know. You are never impolite when you talk to people, but I watch you when you code. You are a different person when you code. You curse so much. And I say, that's called being a programmer, right? Because when you are looking at the code, you get very frustrated because you finally realize what this programmer has done to you, right? And you remove that knife from the back and say, okay, now I will continue coding. That's how you feel about it. With all these hidden changes in the code, this is a deception caused by the programmer at you, and you eventually found out what was going on. And maybe that programmer is like, you finally figured this out, right? And you're like, no, that's not funny, right? You're really angry because it wasted such a precious amount of time. Well, this happens a lot. I'm sure everyone in this room has seen this. There are two kinds of code that frustrates me the most. The first code that frustrates me is, it's a code that does not work. And have you been through that, right? You look at this code and say, why doesn't this damn code work? But even worse, it's a code that works, but it shouldn't. And you're like, why did this work, right? And you're just sitting and staring at this code, and you're like, why does this code work actually? It's not supposed to. And you're trying to understand what made it work, and then eventually you realize, oh, so this is what the programmer has done behind the scenes, and that's extremely frustrating. So we want to definitely avoid these kinds of things in the code. Now, one thing to keep in mind is this really comes down to humanity, because the people maintaining your code are your fellow humans. And a little bit of humanity is like, I'm writing this code, how much pain is it going to cause to the person behind me when they read the code? And we should avoid these invisible changes. So don't sneak around and change the state of objects behind the scenes. Make it absolutely clear to people. That's one way to avoid complexity. One way to avoid complexity is to make things obvious. Now, this is something we have to really take credit for. If you write a piece of code and nobody around you can figure it out very quickly, that's not a sign to be proud. That's something to be really ashamed of, because as a professional, we should really make it very obvious for other people to understand the code, because you have an economic impact in what you do. You minimize the cost of change when other people can understand the changes you are making very instantly. So that's extremely important. So don't sneak around and make these kinds of changes. So in that regard, when it comes to this, ask the question, how much time are you costing for people in your team to understand and maintain the code? The next thing to think about is mutability. Now, we all have done this over and over and over. What is the first thing you do when you start creating a class? You write a class and you make fields available in the class. Then you write methods, and what do these methods do? They start changing state of the object. When you start changing the state of the object, you have to hold all that state in your mind. It becomes really hard to understand. I'm sure everyone in this room has done this at some point, right? You're looking at this long function that's making all these changes to variables, and you're reading this many, many times. You don't get it. And then finally you said, I'm going to sit in a quiet corner, and you take a piece of paper, you write the variable names and the values, and you're just walking through the code. Have you ever done that? That's called the lowest point of programming, right? You don't feel good when you do this. And this is something we do all the time. But when you have to deal with code like that, what happens? It takes every bit of your energy, every bit of your attention. You're just staring at the code, and you're trying to understand how this code works. Now with this, mutability needs company. It often hangs around with bugs. And you discover bugs in code and like, oh, look, this code is failing. I didn't even realize this was causing the problem here. But there is yet another problem we have to deal with when it comes to this. I'm going to go out and say state transition causes brain damage. And there's a reason why programmers are often weird, right? We are weird because we spend more time thinking about how the code works. And when people talk to us, we don't respond too well because we're still thinking about it as we walk around. And this happens a lot. And when we do this, what happens is we have to load all the state in your mind. This is the life of a programmer, because you in this room understand what I'm talking about, right? You're sitting and coding, and you're staring at this, and you're trying to literally build this in your mind. And you're like, this object is talking to this object, here is the state, it makes this call, this variable went from this state, and all this is in your mind. And in the middle of that, somebody walks into the room and says, you want to go for lunch? And then you kind of stare at them. You don't say anything. And then they're like, do you want to go for lunch? And you're like, what? And they're like, you're weird. Is everything okay? No. Look at what you did. Because all that mental model is on the floor now. And you had to put this back into your mind and say, go away. And you're putting this back. And they're going, these programmers are weird, right? No, we're not weird. It is that kind of thing we have to do. You know, being a programmer is a challenge when you get married. My lovely wife, she got married to me. She had no clue what she was getting into. And then she realized she didn't marry me, she married a programmer. And then, when I got married, this was a long time ago, very happily though, but there was a day she said, I want to go shopping. I said, that's a great idea. If you would wait for a few minutes, I'll come and join you. This went on for a couple of years. And then one day, after a few years of marriage, she said, I want to go shopping. I said, absolutely. If you wait for 5 minutes, I'll join you. She took the key and left. I was pretty angry. And then when she came back and said, sweetie, this is not fair. I told you I'll be with you in 5 minutes. You didn't wait for me, you left. And she put her hands on me and said, sweetie, you don't understand this. When you say 5 minutes, that is 7 hours in the real world. And that's when I understood the concept of time is very different for programmers. I mean, you do this, right? Boss comes to you and says, how long would you take to do this? Oh, it'll be done soon. You always say this, oh, done soon, right? Like how long? Oh, it'll be done soon. Like this afternoon. We have no clue what we're talking about, right? and this is because when we get into it, it just takes all the energy. I'll tell you, the best money I ever paid in my life was to watch this movie. I went to watch this movie with my wife, and this is the movie, The Social Network. I'm sure most of you have seen it. And I'm watching this movie, and right in the middle of the movie, there's one scene. And at that scene, my wife literally screamed. I'll show you what that scene is right here. So here's the scene, and there's Sean Parker over there, and he's coming to the place where these guys are sitting and writing code in the early days of Facebook. So let's see what this guy says.
I didn't know we had a doorbell.
Andrew, get the door!
No, he's wired in.
He's wired in.
That's gonna cut into security deposit.
Andrew.
Not now.
Good boy.
I'm Sean Parker. Oh, he's wired in. That's what I'm talking about.
Right at the scene, she screamed, oh my gosh, I get it. And I'm like, what did you get? She's like, I know why you are like this now. You're wired in. And I'm like, take my money. This is worth it. A week later, I was sitting in my kitchen coding away, and one of my children came and said, Daddy, can I have I want to ask you something. And my wife said, don't talk to Daddy, now he's wired in. I'm like, yes, this is worth it. But this is when the spouse actually gets it. My tweet this morning, I didn't really realize this, but this is when you know you're never a programmer alone. Your entire family is a programmer. Because this morning my son said, you know, it's weird that when you start listening to the 80s music, and you always thought your parents were dumb, but you begin to understand this. And my wife replies to him in a very shocking tone. She says, classical musics are exception, and you're handling it well. And I'm like, oh dear God, what have I done? So this is when you know you are not a programmer, you're a programmer as a family. And the beauty is, this is what we do. When people tell you you are antisocial, that's when they have not understood you as a programmer. Now my family knows why I'm weird. My family knows why I think deeply when I sit and code, and they know that they can always talk to me as long as they don't expect me to respond back. And that is the way the life of a programmer is, because we have to deal with that complexity. And complexity is what really hurts us in a lot of different ways. The next problem with complexity is lack of cohesion. What is cohesion? Cohesion is where a piece of code does one thing and one thing really well. That's what cohesion is. So what does cohesion mean? Like things are together, unlike things are apart. When you go into rooms and places, when things are cohesive, you spend less time finding things. When things are not cohesive, you take more times to find this. So you want to really group things together. And when things are together and they are focused and narrow, it reduces the cost of change. When things are not cohesive, it increases the cost of change. It increases the frequency of change. So here is an example of cohesion where you put pens and pencils in a box and you don't put other things like socks into it. But it's not easy, by the way. When I was a child, my parents tried really hard to teach me cohesion. Every day they would tell me, Venkat, you don't do this. When you come back from school, you don't take everything you have and toss into this drawer and run away. But they didn't understand. It was a lot of fun to be out on the street playing, not be home and be lectured by your parents. But you ever open my drawer, I cannot guarantee what you will find there. There will be clothes, some used and some not. There will be books, there will be toys, sometimes snakes as well. It was a disaster. It's like some tornado went through this. And if you ever reached in and took a blue sock, the next one will not be a blue sock. This was optimized to throw things in, never to take things out. Like the code we write, optimized to write the code, never to read it. And of course, they tried really hard and said, that's not the way we keep things. We put things away. But I never got it. I know what you're thinking. You're thinking, gosh, this guy sounds really awful. How is it that this guy turned out to be the way he is? Well, in my case, I got married. That took care of everything for me. Now the beauty is, kitchen has utensils. What a concept. Books are on the bookshelf. Clothes are in a separate drawer. And what is that called? Cohesion. Same thing with code. You put UI code in one place, the code that accesses database in another place. You don't mingle them all together because that becomes lack of cohesion. You don't put JSP pages in HTML. That's lack of cohesion. So we need to really be cognizant of that and say, hey, do these things belong together or should we separate? A separation of concern reduces complexity. So lack of cohesion increases complexity. More cohesion removes that accidental complexity. Keep in mind, we're talking about accidental complexities. These are complexities introduced by the solution space, and we can play an active role to minimize those things in code. So the code that is narrow and focused and does one thing well really makes things easy for us. And as a result, it reduces the frequency of change, and as a result, it becomes more economical to build the software. I remember a wonderful experience a few years ago. There is a conference called something along the names of, I'm paraphrasing here, this is a computer science undergraduate student conference. What is absolutely phenomenal about this conference is this is run entirely by undergraduate students in Canadian universities. My mind was blown because there's no professors involved, there's no other people involved. This is purely a conference run by undergraduate students who go to universities in Canada. The second thing that blew my mind is they organize this conference once a year. Rule number 3, they never invite the same person again. Rule number 4, they always invite the top luminaries from the industry. And it so happened that once I got the wonderful opportunity to get invited, when I went there, every year they also run a competition along with this conference. And that year the competition was build stuff with Legos. And so the students, teams of students, brought Legos and they started building things with Legos. And the number of combinations and things they had developed was almost endless in terms of what they had built with it. And I stood there just watching all these different things they have built, and immediately my mind gets back to software development. I said to myself, what a beautiful idea of cohesion. Legos are a wonderful example of cohesion. These are extremely small blocks, but the number of combination and permutation we can put together to build things on is almost infinite. And that's a really good example of how you can build something really big using very small cohesive parts in your application. That's just unbelievably powerful. Well, the next thing to think about is dependencies. We deal with excessive dependencies in applications. I was here actually in New Delhi working with the team a couple of years ago. And one of the developers told me, oh, in this JavaScript application, we used to run automated tests, but now we quit running them. And I said, why did you quit running them? Oh, because we upgraded some of our dependencies and nothing works anymore, so we quit running those. This was a JavaScript application. I know what those application was. And in my mind, for this application, maybe you should have these many dependencies. And I asked him, how many dependencies do you have in this application? He kind of shrugged and said, 150 dependencies, I think. I said, you think? He immediately opens up the dependency file and shows me, sure enough, there's more than 150 dependencies in there. And I asked him, why are you using all these dependencies? He said, because we found them. And that is so true in the JavaScript world, isn't it? You go to lunch, and while you're having lunch with your colleague, you hear people in the next table talk about a new framework. And you're like, oh my gosh, we never heard of it. You come back from lunch 15 minutes later, one of your colleagues took care of it. Right? And you're like, why are you using it? I heard it during lunch. I mean, if we don't use it, what would people think of us, right? I mean, just pollution of dependencies on applications to a scary level, isn't it? Well, I've lived from different types of hells. I've had one hell of a programming life, from DLL hell to jar hell, through assembly hell, through NPM hell. This NPM hell is special. The other day I was on the flight. I didn't mean any ill will. I wanted to let you know that. I was on the flight, and the captain said, we got a really smooth ride, folks. I'm turning off the seat belt. So he turned off the seat belt, and all I did honestly is nothing else. I just did npm install. Turbulence immediately. I'm like, sorry, I didn't mean to do that. And this can be really cause havoc. I'd never turn on Wi-Fi anymore in airplanes because of this reason. Well, all this dependency, you use npm, it'll download the entire internet with vengeance. I know what you're thinking. You're thinking, hey, we don't have that problem because we are using Maven. I want you to know this. See, I mentioned the word Maven. You're not using Maven. Maven uses you. So with dependencies, you get dragged into it. It becomes really hard to manage the dependencies. Dependencies are accidental complexity. This is not what you need to do to solve your application, but yet you get dragged into it. And that becomes really, really hard, and you need to be very careful about it. So when it comes to this, ask the question, do I really need these dependencies, or can I eliminate some of these dependencies and in the process reduce accidental complexity in my applications? Dependencies are really hard to maintain. They become obsolete really quickly, and they also become really incompatible. And one of the smartnesses of us as developers is to reduce dependencies. I'm not saying you can eliminate all of them, but the smartness is to really reduce them as much as you can. And as much as we can reduce the dependencies, we are better. Well, I'm going to put a word to this. I'm going to call this as technology infatuation. And we live in this day of technology infatuation because every corner we turn around, we ask the question, what are you using and why am I not using in my application? And that becomes really a dangerous factor in applications. And so what are the 4 uses of frameworks? I'm going to say they are reuse, confuse, misuse, and overuse. The reuse is only a small part, but unfortunately it carries with us the other 3 things as well that we have to deal with. I'm not suggesting by any means that the past was better than the present, but I will tell you how things were in the past. When I was a kid, very young programmer, life was very different, which is a little annoying because my children would often look at me and says, what do you mean there was no internet when you were a programmer as a child? And I have to tell them there was no internet, and they're like, really? There was a time when there was no Google? And they look at me like I'm very ancient. It's really hard. And it's really hard to explain to them that yes, we actually used to physically walk to libraries and actually request books and wait for a few weeks to get them. And there was a time when we didn't have this internet. We couldn't download software. There was no concept of downloading. And I would read about some particular library in a magazine. Then I would understand what it is, go to the boss and say, here's a library, I would like to purchase it, it'll be useful for our product. And then we go through weeks of negotiation about it. And then the boss says, okay, you can order it. And we will place this order. And then we will wait patiently for it to arrive in the mail. And then when it arrives in the mail, then you painstakingly take the tape drive and you install the tape drive and you start installing it. And that is how I install products. When you are use of a tool and there's in between you and the tool that you want to use, there's a tape drive involved, you think several times about it. Trust me, it's not fun to install things from a tape drive. But today, we live in a very different world. Somebody says a particular library they are using in the middle of sneezing. Next thing you know, we have downloaded it and we have installed it. And it is so easy, so accessible. I'm not complaining that it's really easy and accessible, but the point is, there is no restraint at this point. And then what is there to stop us? And suddenly all these dependencies, because it's so easy to install, becomes really hard. This leads to what I call as a resume-driven development. And people start putting all kinds of things on their resume. Resumes are a scary place. I look at people's resume, you look at it and you look for what is not there, right? Because you're like, it's like a dictionary. And you look at all this, you know all of this, and like, yeah. You have used all of this? And they are like so proud. Of course. Every one of them in one project. And you hire me. I will come and kill your project the same way, right? Scary. I hire people who don't have many things on their resume. Not if they have a lot on it, because I want to know how they can get me success, not failure, right? So I don't want all these dependencies to be dragged into my environment. That's very dangerous proportion, if you will. So I'm going to call this as a tale of infatuation. It's a pretty sad story. It's a sad story, but unfortunately, it is true. This was a few decades ago. And this was a time of recession in the US. A lot of people didn't have jobs. And I was so fortunate to have a job as a consultant in a company that I was consulting with. And as I was consulting with them, this was a project, everything was going really well. We were having a blast, and we were developing something, and we had extreme visibility in this small company. And as we were doing this, we had to really hire people to work with us. So we went on to interview people. And it's interesting, when the country is having recession is also the time when it's really hard to hire good people as well. And after interviewing several people, we came across one person who was absolutely phenomenal. And my jaws were on the floor listening to this guy. I said, wow, this guy is brilliant. And I was very selfish. I said, I want to work with him, because if I work with him, I can learn everything from him. So I was hoping, I hope he comes and joins on our team. So my boss came to me and said, hey, what do you think of this guy? I said, oh my gosh, you're asking me why this guy? Come on, go now, hire him. Let him not go take another job. We need this guy, he's brilliant. Yeah, we know he's brilliant. But what do you think of hiring this guy? Like, go hire him now. What do you think of the framework he's been developing? Oh, that's the best framework I've ever seen. Brilliant. I've never heard anything like that. But anyway, that's besides the point. Go hire him. Yeah. But what do you think of us using the framework? I said, excuse me, put down your gun. I was programming in Texas. This is normal. Put down your gun. Sit down quietly for me. Let's talk about it. Hire him. Let's use him for what he is. Please do not talk about the framework. He's like, yeah, but I just want to get your input. Don't talk about the framework. But Venkat, did you notice how he had persistent messaging? I said, look, you never use the words persistent and messaging in one sentence ever to me. Why are you saying it now? Well, did you notice how he's handling the distributed database and transactions? Those words you never used in a sentence before. Why are you using it now? Well, it's a great framework. I said, no, you're infatuated. Don't do this. 2 weeks went by. I was sitting at my desk when he comes over and says, Venkat, I got a news for you. We hired this guy. I said, I'm the happiest person in the world. I can tell you how excited I am. We're going to have a blast. We're going to learn everything we can from him. We're going to build this product. You found the right guy. I can't tell you how happy I am. Honestly, thank you for this news. Oh, by the way, as part of the hiring contract, we agreed to use this framework. I said, tell me you're kidding. Tell me you're just joking to make me angry. Like, no. We signed the contract already. I said, well, that means I just turned in my resignation right now. Oh, I know you're going to say this. I already told my boss you're going to quit as soon as you know this. I said, hey, at least I'm not unpredictable. There's something to do this. I'm leaving, but anyway, if you have other jobs, please call me. I'll be delighted to come and work with you. But we're done. Oh, when do you think you're going to get done? Oh, we're still on schedule. 6 months, we'll release it. I said, good luck. What you don't want is somebody like me who's going to come to you every day and say you are wrong. You need people who will push you forward and take you where you want to go. That's not me. Good luck. And I walked away. This is one of the very rare moments when I actually come to home on time or early. I walked into my house. My wife is like, hey, you're very early today. Yeah, I quit. You quit? Like, yeah. Well, I got some dishes for you if you want to help me in the kitchen. That's the way she is, right? So we roll with the punches. And I kind of was without job for about a couple of weeks, found something else, moved on. And this was in February of the year. 18 months later, my phone rings. I pick up the phone and said, hello. I said, hey, Venkat. Hey, how's it going? Hey, go ahead and say it. I said, I'm sorry. Go ahead and say it. Sorry, say what? Go ahead and say it. I told you so. I said, oh my God, no. What happened? Well, we spent the 18 months and the framework did almost everything we wanted it to do. Remember, we didn't want the framework to do anything in the first place. Well, we're not done with it yet. I said, really? That's really sad. What can I do for you? I was wondering if you can come and help us to fix the problems. There's a reason I ran from you guys. No, why would I want to come now when everything is dead? And this is the scary part we live in. People don't see where they're heading. They get so infatuated that they want to use solutions and they forget the problem they are solving in the process. So never lose sight of the problem you're solving in the spirit of solving a problem you have at hand, and that's extremely important. So don't build what you can download, and please don't ever download what you really don't need. This is one of the biggest challenges we deal with, is where we start using stuff that we really don't need, and that's not a really good thing to do, so we have to be very careful about it. So dependencies again, and not bringing in things we don't really need. Let's be very specific about some accidental complexities we deal with. The first accidental complexity, I would argue that JDK library for concurrency itself is an accidental complexity. It really makes life a lot harder for programmers in general. If you ask me, what's the scariest book ever written for programmers? I would say that book is Java Concurrency in Practice by Brian Getz. It's like the Stephen King novel for the programmers. Before I read the book, I used to think programmers can never get concurrency correct. After reading the book, I know programmers can never get concurrency correct. It is that scary. Because the amount of complexity you have to deal with, I'm going to say the JDK concurrency library is the assembly language for concurrent programming. What do I mean by that? How many of you program in assembly language? Did I see any hands? Wave at me if you do. Sir, thank you for being there for us. You do it so the rest of us don't have to do it, right? And there's a reason why we don't do program in that low level of abstraction. JDK library is like that. If I ask you who programs in the JDK library, I want one person to raise the hand. Every one of us should be using a higher level of abstraction that in turn uses the JDK concurrency library. Why? Because it's inherently complex. It is accidental complexity in the solution space. We look at a problem and say, hey, we can solve this using a pool of threads. Now we have a pool of problems to deal with. Let's take a look at what that really means. Here's a little code example for you to think about. So notice what I have here. I've got a variable called done. Very simple code, right? Variable called done. Then I have a done equal to false. That's the first thing I do in the code. Then I create a thread. Within the thread, I say running. Then I say count equal to 0. While done is false, continue incrementing the count. Eventually, when the done is true, get out and print exiting thread. I start the thread. Then I wait for about 2 seconds. Then I set done to be true so that the while loop will be able to see that the done is not false anymore. And I end the main. When I look at the code, what's going to happen when I run this code is the question, isn't it? You can look at the code, you can analyze the code, you can eyeball it. You can show it to your colleague and you say, what is the code going to do? And most of us would say, oh, the code is going to be looping through here, and then 2 seconds later, this is going to be turned to done equal to true, and then the thread is going to exit. Well, wishful thinking. Let's see if that's what is going to happen here. So right here, I'm going to go ahead and run that little code that we just wrote. Let me save that. So run the code, and what is the code doing now? It's running. 2 seconds later, setting is done to, we have set done to true. But what just happened here? Did you notice the program is still running? Should we wait a little longer? How long? Forever. Rule of life. You never wait forever. What is the first thing you learn in in concurrent programming? What's the first idea? Time out. I would recommend both in life and in programming, never do anything without timeouts. I always tell young people about it. If you're going to find perfect love, put a timeout. Otherwise, you're going to get old and die alone. Same thing in programming. You put a timeout and say, you know what, I'm going to wait for some time. And I'm going to exit right after that. And that is extremely important. In this case, how long do we wait? Forever. Forever is never a good idea, right? What went wrong here? It's even worse. Notice what I'm going to do here in the code. I'm going to come in here, and I'm going to say try, and I'm going to say over here within this little piece of code, and what am I going to call to add insult to injury? Here I'm going to simply say a thread.sleep 0. Did you notice that? I'm not sleeping at all. Thread.sleep 0. That's all I put right here. Now I go back over here to the code, run exactly the same code with only that one change of a sleep 0. How do you reason that code? This is a great interview question, right? Show this to people and say, why does it work when you put a sleep 0? You're not even sleeping, right? This is an example of accidental complexity in concurrent programming. Because the threads have to cross the memory barrier. Most programmers programming the concurrency model haven't understood the Java memory model. If we don't understand the Java memory model, the chances of getting concurrency right is close to 0. These are enormous complexity we have to deal with in programming. These are bugs. You could easily burn days on bugs like this that will not allow you to move forward in your application. Very high complexity. A key design skill we need to develop is the ability to discern accidental complexity from inherent complexity. That's why when I wrote the concurrency book, I said, I call this the synchronize and suffer model. That's the name I gave for this chapter. The chapter title is called Synchronize and Suffer because when you start using the JDK concurrency, the result is suffering. You're not getting solution from it as easily. You want to raise a level of abstraction so you can handle that. So that's when you recognize the accidental complexity and say, I don't need to deal with this level of complexity, I can do better. And well, accidental complexity is in a lot of other places. Imperative style code is inherently complex. Let's look at an example of this real quick. So here is a little example I want to start with. So here is a code where I have an n is 101 and k is 51. So help me here for a minute. I want to compute with this n and k. What does compute do? The compute says, find the total of the square root of the first k prime numbers starting with n. That's not rocket science, right? You want to find the total of the square root of the first k prime numbers that start with n. How difficult would that be? So let's try it, can we? So what's the first thing I'm going to do? I'm going to say result, well, double result is equal to 0. I want to return the result when I'm done with it, right? That's what I want to do here. Great. Then what am I going to say? Int index is equal to n. Int count is equal to 0. So far, so good? Yeah, pretty simple, isn't it? What did we do so far? Absolutely nothing useful. Just defined a bunch of variables, right? Then what do? While count is less than k, at this point, your brain comes to a screeching halt, and you ask that vexing question, is it less than or equal to? Do you ever ask this question? Every single time. If your children ever ask you, what's that symbol less than? You tell them, that's a symbol that makes us feel stupid. That's what we use in programming, right? Because you write this, and then the entire world becomes silent around you. And then you're like, less than or equal to? You're trying to manage this, right? You're never sure about it. You're going to the restroom. You're still thinking. Your colleague on the way says, hey. After delay, it's like, hey. Because you're still thinking about it. You're having meal with your family. Your family says, are you okay? Is something wrong at work? No, everything is fine. Is somebody mad at work? No, everything is fine. You look a little, frustrated. I'm telling you, everything is fine. Just not sure if it's less than or equal to, right? This is just unbelievably complex. That little thing can cause so much pain, right? Then what do? Then you say if, and then you say is prime of index. Okay, great. I found the prime of index. What do I do now? Result plus equal to math dot square root of index. There you go. Is the code correct? Yes or no? Come on, programmers, room full of programmers. Is the code correct or no? No, what am I missing? Increment the index. Thank you. I was beginning to doubt if I was another place. Is it good now? What am I missing? Oh, increment the count. Thank you. Is it correct now? No, what's wrong? Oh, it should be outside. Fine, moved it. Is it good now? No. Oh, this should be inside. That should be. How do you feel about this? Is the code correct now? Did you notice? You kept saying no. And now I ask you, is it correct? Everybody's like, I'm still thinking. I'll tell you, programmers are the smartest people on earth. Because when you show them code and ask them, is it correct? They never tell you it's correct. They tell you it looks good. Because they know. You never say it is correct. It looks good. Because 3 weeks from now, we can't stand by our words. See, be careful what you say, right? It just looks good. What is this? This is accidental complexity. This is accidental complexity. Why? The problem is simple. The solution tortures you. And how much time and effort it takes to understand this code? You got to stare at it. You have to tone down the music. You tell people around you, could you please quiet? I'm trying to concentrate here, right? And then we try to put everything we have to understand the code. Shall we try this one more time? Let's try a little differently. Same exact problem, isn't it? Now I'm going to say return stream.iterate. What am I saying here? Given a value n, given an element, give me element plus 1. We got an infinite stream of numbers. Filter. Given an element, I want to know only elements that are prime numbers, is prime. Map, what's the next thing I'm going to do? Math, square root. I found the square root of all the values so far. Then what do? Dot limit. Limit what? K. You say, hey, wait. Is it K or less than K or it's K, damn it, keep moving. You don't have to worry about it, right? And then you run the code, it produces a result. You don't have to loop back and forth and back and forth and back and forth. It's a single pass through the code. You can actually read the code in one trip. Given all the numbers, give me only the prime numbers, but give me the square root of those, but only K of them, and total it. The code begins to read like a problem statement. When a code begins to read like the problem statement, what did you do? You retain the inherent complexity and you remove the accidental complexity. Our job as programmers is to keep the inherent complexity manageable and remove the accidental complexity. That's what our strength is. When we sit down at work and say, that complexity is accidental, folks, find a way to remove it. Because keeping it there is suffering. We don't need to do that, right? That is the key, is to really identify that and get rid of that from code. So, in other words, declarative helps us to keep focus and focus on what's needed rather than get dragged into how. And that's what we saw. The last thing I want to talk about here is called entwinement. There are other names for this too. It's a very common mistake we all do. When I say we all humans do. You and I are not the only people subject to this. Every single person is subject to this. As much as even the Java JDK, the language itself, is subject to this, as we'll see here. So here's an example of a piece of code called resource. This resource class is going to have an external resource, let's call that. So notice the resource created in the constructor. I have an op1 and op2, two functions. In the finalize, I say clean up non-memory resource. Well, Java cleans up memory for you automatically. But what about the memory that is external? What if this was using a file? What if this was using an external socket? What if this was having a connection to a database? How do I clean those things up? If I said resource equal to new resource right here, I called resource.op1 and resource.op2, what's going to happen here? When I run this code, notice that it does not clean up. It just printed op1 and op2, but it did not call the cleanup code. Why? Because finalize is called when the garbage collector kicks in. The garbage collector does not kick in when there's a lot of memory. So memory management is one thing. The other thing you want to handle is, how do you deal with cleaning up external resources? These two are orthogonal to one another. One of the fallacies of computer programming is to take two things that are independent and bring them together. That often is a mess. It's not just us, the programmers, who get dragged into it. Even the folks who wrote Java got into this without realizing it. This is why they are fixing it now. How do you deal with this now? They finally deprecated finalize for that reason, as you can see here. That's Java 9. Java 9, you shouldn't use finalize. Then what do? They want you to implement. So implements over here, auto-closable. Then what you can do is convert this to a close method. Then when you come down here, you say try with resource. And you try to create this within this object, call the method right here. And you said to Java, thank you, you take care of memory management, but I will take care of cleaning up, so auto-closable, and I will take care of really dealing with the external resources. You are separating, you are untangling two things that got tangled together. This is what we do, right? We call this conflict of interest in our own lives. We say, don't take two separate things and mix them together. In fact, this concept is so prevalent, this accidental complexity is so prevalent that Rich Hickey coined a new term in English for that. He calls this complecting. Complecting things is the source of complexity, he says. That was just one example of complecting we just saw, the entwinement. So as a developer, one of the strengths we need to develop is, one of the skills we need to develop is to look at a problem and say, folks, did you take two things that shouldn't belong together and you brought it together? That's what I do as a consultant when I go to companies. When they are suffering through problems, I look at it and say, why are you bringing these two things together? And they would say, because, and they would have all these excuses. And then ask the question, if we separate these, what will happen? And you end up really making things less complex by separating things out, just like in this example, what they've done in Java. So that complecting or entwinement is another thing we should really look for. So we should learn to deal with complexity and have the wisdom to minimize it. So if you ask me, what is it to be an experienced programmer? An experienced programmer is not a person who can write a lot of code. An experienced programmer is one who can write less code and solve the problem. I would say this is the experience. Right? This is what is called experience. Here's a challenge for you. Stand by the door and you watch this wonderful young girl, young lady walk through the door. Just finished college or barely finishing college, and you ask her, where are you going? And she says, I'm going to walk into this building, write all that code and change the world. Just stand by the door for 15 years. That same lady walks through the door and you ask her, where are you going? And she says, I'm going to walk through this building and go remove all that stupid code we have written and change the world. That's called experience. Experience is not putting more, experience is putting less. Experience is solving real problems and reducing the complexity that we get tangled into. So the strength of you as an experienced developer is identifying what shouldn't be done more than what should be done. When people ask me, what can you do? I'm wondering what I can do, what I don't want to do, what I shouldn't be doing, so I can focus on solving real problems than getting dragged into this accidental complexity. And there's one other reason to do this, and that is a maintainable code is a gift, a gift ourselves for the future. When you write a maintainable code, the future you comes and thanks you. And one day, your future you says, thank you for not writing that code 6 months ago. I know you were tempted, but I'm so glad you had the wisdom, and now I can have a good day today. I can leave for home on time and not deal with the tangled mess that you yourself created 6 months ago. So when you write a maintainable code, the future us thank ourselves, and that's definitely worth doing it. Hope that was useful. Thank you.